Good morning, students. Today I am going to explain about how to interface EEPROM with Arduino controller. So, what is meant by memory interfacing? So, why we are going for memory interfacing? If you take Arduino controller, we have inbuilt. There are two types of memories available. One is RAM, another one is ROM. So, RAM is used for storing temporary data, and ROM it is used for storing permanent data, example program, code, etc. But when you go for some high application, this memory capacity is not enough. So what you are doing, you have to connect an external memory. So inbuilt RAM is available. That RAM capacity is not enough for some applications. So we need some external memory. So external, we can connect various types of memory. We can connect RAM. There are two types of RAM: static RAM, dynamic RAM, or EEPROM. Next one is PROM, ROM, flash memory, or any type of memory we can connect. So today we are going to study about how to interface a EEPROM with Arduino controller. So the IC number is 24LC256. So this is the IC number of the EEPROM. So what is my EEPROM means? Electrically erasable programmable read-one memory. It is called as non-volatile memory. So there are two types of memory. One is called as volatile memory, another one is called as non-volatile. So non-volatile means if you take memory, if the power is, there is no power, suddenly the power is cut off, automatically what will happen means the data stored in the memory will get erased. That is called as an volatile memory. Next, non-volatile means if the power is shut down also, the program is available in the memory. That is called as a permanent memory. So if the power is cut off n number of time also, the programs will be available or data will be available in the memory. That types are called as a non-volatile. ROM, PROM, EEPROM, these are called as a non-volatile. So this is called as a permanent memory. So this permanent memory, it is used for storing the code or program, etc. So here some ROM means only we can read the data. So we cannot write the data. So once if you write, we cannot change the data also. Our program we cannot change. So we are going for EEPROM. So EEPROM, we can write the data as well as we can read the data. That is the main advantage of EEPROM. So this is the IC number 24LC256. This is the EEPROM chip. So it consists of 8 pins. So you can store 256 kilobytes. So if you take one IC, the capacity of this one IC is called as 256 kilobytes. Suppose I'm having some applications, I need some 200 kilobytes of memory, extra memory. So we can connect one EEPROM. Suppose I need 500 kilobytes of memory. So we have to go for one more EEPROM. So depend upon applications, your memory capacity will get changed. So if you need some 2 kilobytes means that is called as 10 10 IC we can interface. So depend upon the application, depend upon the memory capacity you need, we can interface the memory. So we can read and we can write the data and we can erase the data. There is a main advantage of EEPROM. So here there are 8 pins are there. So what is the first pin is, one is called as an VCC, another one is called as a ground pin, another one is called as 3 address pins, another one is called as SDA, another one is called as SCL. First, VCC means supply. Next one is VSS means that is called as a ground pin. Next, these 3 pin is called as an address. A0, A1, A2 is called as an address. Next, what is meant by address? I'm going to connect 8 IC to the Arduino controller. So 8 IC is available. So each IC I want to differentiate the address. So here 3 is available, 3 pins are available. So 2 power 3 is nothing but 8. So here you have to give 0. A0 is 0, A1 is 0, A2 is 0. If you give this 3 value as 0, first memory will be selected. If you give 001 means second memory will be selected. 010 means third memory. 111 means eighth memory will be selected. So maximum by using this EEPROM we can connect maximum 8 memories. To one memory capacity is 256 kilobyte. So maximum we can connect 8. Suppose we need more memory means we can go for some other IC. So 3 pin is called as address. So maximum 8 ICs we can connect with Arduino controller. One is supply VCC, another one is ground, another one is WP. WP means it is called as write protector. So if you give a low signal, we can do the write operation. If you give a high signal means we cannot write the data in the memory. So that is called as write protector. If the particular pin is 0, we can write the data in the memory. The particular pin is 1 means we cannot write the data, only we can read the data. Next one, STA and SCL. We have studied about I square C bus in the second unit. Inter-indicator circuit. The Arduino and this memory is connected by I square C bus. So I square C bus, it requires only 2 lines. So one is called as serial data, another one is called as a serial clock. So the data from memory is transferred to microcontroller through this I square C bus. It is a serial communication. By using 2 lines, we can transfer the data from memory to controller, next controller to memory. Read means it will read the data from the memory and it will store in the controller. Write means it will write the data from the controller to memory. So this is the pin diagram of EEPROM IC. So there are, I already explained about address. There are 3 addresses are available. So 2 power 3 is nothing but maximum we can connect 8 ICs. So each memory, the capacity is 256 kilobytes. So this is all about the EEPROM IC. So this is the connection of Arduino controller. So this is the Arduino controller. This is called EEPROM. So the pin number 5 and 6 it is called as an I square C bus. So it is connected to STA and SCL. One is connected to the serial data, 5 is serial data and 6 is clock. It is connected to the Arduino controller. Next, 7 is connected to the ground because if it is 0 means that is called as write is enabled. We can read the data and write the data. And this is called as VCC. So I am giving the positive supply 5 volt. Fourth pin is ground. Next, see here these 3 pins A0, A1 and A2. Both are all are 0. So if it is 0 means first IC is interfaced with the Arduino controller. If you connect 8 means second you have to give us 001. Third you have to give us 010. Like that you have to give the different address. This is the hardware connections. How to connect the Arduino controller with EEPROM IC. After connection, you have to write the program. So program I will explain in the separate topics. So today I am going to explain only the hardware connections. So this is all the explanation I got given for the hardware connections. So the address of the EEPROM is normally 50. Suppose you are connecting only one IC means, so the IC address is 50. Suppose you are connecting two IC means one address, one IC address is 50, another address is 51. If you connecting 3 means 0, 50, 51, 52. Like that, the address value is changed. So based on the address only, we will send the data to the memory. Suppose you are connecting 8 IC. So what happens means each IC you assume that 200 kilobytes. So 8 into T means 1600 kilobytes. So first 200 memory location, it is allocated for first EEPROM. Next memory 200 to 400, 400 to 600, 600 to 800. Like that, address will be assigned. So if I want to store the data in 1500 address means automatically you have to select the address 57. Suppose I want to store the data in the memory 100. Location is 100 means you have to select the first memory. So the address is 50. So like that address will get changed.